This is Unit 1, the Alphabet and Grammar of Geometry, Lesson 1.4, Problem Solving. Okay, students, remember as you watch this, you want to record both the date, time, and location and get a parent signature. Please don't multitask while you're doing this, so turn off all distractions, TV, background videos, Facebook, Instagram, whatever is you're dividing your attention at the moment. Please focus only on this. Okay, as a quick review, we're going to graph this line, and you could either use intercepts or y equals mx plus b. I'm going to set the timer for a minute, your choice. So attempt to graph this problem. Okay, so let's see how you did here. There's two ways to do this. You could have used intercepts or changed it to y equals mx plus b. So right here, first I'm going to change it to y equals mx plus b. So I have 9x minus 3y equals 15. The goal is to get y by itself. So I'm going to start by minusing 9x. End up with negative 3y equals negative 9x plus 15. Divide by negative 3 all the way around. And I end up with y equals 9 divided by 3, double negative makes a positive. So I'm going to 3 over 1x minus 5. Or I could have used intercepts, which would have looked like this. If I have 9x minus 3y equals 15. And my intercepts, I'm going to go blank, 0, and 0, blank. So if I put a 0 in the y, I end up with 9x equals 15. Therefore, x is going to equal 5 over 3, which is 1 2/3. So 1 2/3. If I put a 0 in the x, I end up with negative 3y equals 15. Therefore, y is at negative 5. Okay, let's go ahead and graph this and see what happens. So for y equals mx plus b, I'm going to start by graphing the negative 5. So I should have a negative 5 here. And up 3 over 1, and it's positive. So 1, 2, 3 over 1. 1, 2, 3 over 1. I could have gone down this way. Either way, it should look like this. Now, just check the intercepts. One of my intercepts is going to be 0, negative 5. That's my y-intercept. My x-intercept is 1 2/3. So 1 and a little bit over, and 2/3, 1 2/3, and 0. Let me bring this close so it's easy to see. So we have here, there's your intercepts, and there's your line. Okay, today's going to be quite revolutionary if you understand what I'm going to talk about. We're going to be talking a lot about your brain today, about for the next half an hour, and as we do this, keep in mind these words: neurons, frontal cortex, digital immigrant, digital native, hypertext skimming, and linear reading. So neurons, those are the nerves in your brain. They look like this. Okay, frontal cortex is the front part of your brain. So the frontal cortex, that's the conscious thinking part of your brain. Digital immigrant, that means someone who came to digital technology as a late teen or early adult, or later. In other words, they did not grow up with digital technology. So basically think me, your teacher. That would be me. Digital native, that's basically you guys. You grow up with digital technology. You've been using computers, internets, and smartphones and iPads since you were tots. Hypertext skimming means to skim a text. Linear reading means to read word for word in our culture, left to right. Let me tell you what sparked this particular research, my personal research. Starting around 2007, 8, and 9, I noticed when I was doing problems on the board, okay, something very simple, and let's say involving triangles and the measure of triangles, 50 degrees, let's say this was 50 degrees and 70 degrees, and I simply asked students to find this last angle. I started getting students in tutoring that had their arms wrapped around their chest or not even holding a pencil, and I'd get this defeated, I don't get it. They're looking at the diagram, but even though this problem is insanely easy, students were getting hung up and not even comprehending the information. And I started doing some research on why it seems like some of the simplest problems were getting increasingly difficult for students. And my research led me to believe these four simple discoveries. Four simple discoveries. Okay, notice where the students' hands are. The students' hands they were not physically touching the board. They were not physically tracing the triangle. They were not physically interacting with the physical diagram. Therefore, they didn't understand the information. So I've done some research over the past decade, and here are some four simple things you need to understand. One, your fingertips are physically connected to your frontal cortex. That means the thinking part of your brain, the way you process information, is physically connected to your fingertips. Your fingertips, as you explore your world, as you draw, as you physically handle things, your brain is gathering information and processing it through your fingertips. I have, if some of what I'm saying, if it sounds insane, I have citations for everything, so you're welcome to look that up if you choose to. So that's thought number one. Your fingertips are physically connected to the thinking part of your brain, called your frontal cortex. Number two, digital technology usage is physically reshaping the way our brains are wired. It's changing the way we process information. Again, if you are interested about a citation, especially parents, if you might be watching this video, highly recommend the book called The iBrain, written by Dr. Gary Small and Gigi Vorgan, Surviving the Technological Alteration of the Modern Mind. Now, how is technology shaping the way our brains are connected? Well, one, we're keyboarding more than we're physically writing. And studies show the more you physically write, especially when you're younger, it connects the neurons in your brain in a much closer manner than when we keyboard. to, instead of physically coloring, physically drawing, we are now doing more clicking on things. And that is changing our ability to understand visual and spatial relationships. And last, we are tapping on more things. Then we are physically touching. So we're tapping on screens instead of making physical models. And all of this, removing our fingers from interaction with the physical world, is changing the way our brain is processing information. Again, the citation reference is called the eye brain. Number 3, screen reading is different than print reading. Very important you understand this. You're all going to look at the book called Into the Shallows, what the internet is doing to our brains. So when our eyeballs hit a screen, we tend to skim automatically. It's just the way our brains are wired, and there's something about digital technology. Compared to print reading, we tend to read linear. Now, problem is, all of us are on iPads in this school, so I'm going to give you some techniques that even when your eyeballs hit a screen, you can train them to read for detail, and there's some things I'm going to train you to do that work even when you are using an iPad. But by and large, when your eyeballs hit a digital screen, they tend to automatically default into skimming, not detailed reading. Finally, there's a contrast. The increasing hand-finger usage increases brain function, connects neurons. So the more you physically write, like a journal, the more you play an instrument, that's my meager attempt at, let's say, a cello, or a guitar, whatever. The more you draw and paint, the more you work with clay, the more interactive that you're using your fingertips in the physical world, it does increase neuron connections. Once again, there are citations. If this is sounding a little out there, I do have citations for everything I'm saying. So those 4 truths, let me recap those. The 4 simple things discovery. Number 1, your fingers are connected to your frontal cortex. Number 2, technology usage is reshaping our brains. Number 3, screen reading is different than print reading. Number 4, increased hand-finger usage, increased brain function. Therefore, it all leads to this. When you're working in my class, you're going to hear me use a term, a phraseology, in which I tell you your brain is in your hand. Now, when I use that cue, there's certain things that you're going to be learning to do in this class. 1, you're going to learn to do what's called finger track and read. You're going to learn something called filtering. You're going to increase your instincts to draw things, label things, list things, cross them out. When you interact with diagrams, which geometry is all diagrams, you're going to learn to trace and sweep, trace and mark, trace and stretch, finger shade, block and compare. You're interacting with your fingertips physically on diagrams. There's a technique I call squeeze the sponge, in which you are never passive in this class. If you don't know what to do, you start working on what you can do and that you are familiar with. You never allow passivity to keep you from attempting something. When you write out equations, you will physically write out all equations. You never keep them in your head. You write them out with 2 sides and an equal sign. When you use equations, you're going to physically do circle, plug, chug. As you work through equations, you will box and label your answers so you didn't get lost. And then you'll take a moment and you're going to check on your work. I'm going to work this through with you on a couple problems. Now, whenever you get stuck in this class, You have this sheet on the inside of your reference folder. It's also the giant posters on the front of the classroom. When you don't know what to do, this is what you can do. You are never passive in this class. That's the main skill I want you to learn, is how to put forth effort even when you don't know what you're doing. That's very critical. Okay? So you're going to read through this list. I'm going to set the timer. I'd like you to physically finger track and read each of these points out loud. Please do this. There's nobody watching you, but you're going to do it because I'm your great teacher and you're my great and honest student. So put your finger on number 1, and I'd like you to read 1 through 14 out loud to yourself in the next minute. 1 through 13. Ready? Read it out loud with your finger on the paper, tracking go. All right, so when you're stuck, you can go to this sheet and just start working yourself 1 through 13. Basically, what you need to understand is this. Effort is what leads to understanding. It's not the other way around, students. You don't understand something first and then put forth effort. Really critical you get that. You got to learn to put forth effort, to put forth sweat, even when you don't understand something. And if you're like, I don't even know where to start, that's what this page is for. Learn to use this page as much as you can. Okay, learn to put forth effort even when you don't know what you're doing. Okay, so instead, you don't understand first. Okay, and then put forth effort. Please don't be this person. I don't get it, therefore I quit. That is very important. You are not passive in this class. Okay, all right, ready? What I'd like you to do is just look at this. Don't do anything. Just watch as I read. Ready? I'm going to read it out loud. Mr. Fareed wants to create a rectangular cement patio in his backyard along the side of his house. The length of the backyard is 8 feet longer than the width. Each bag of cement costs $6.50 and will cover 12.5 feet squared. The perimeter of the backyard is 64 feet. Tax on the subtotal is 10%. Find the total cost of the cement backyard. Now, without any other thought, if I were to ask you to solve this problem, I'd like you to rate it on a scale of 1, super easy, to 5 being I'm dying here. Ready? Rate. How difficult do you think this word problem is going to be? All right, now before we solve that word problem, let me just recap a couple of really important equations here for you. Number 1, when we're dealing with a rectangular perimeter, I want you to think picket fence. Perimeter, picket fence. Say those out loud, please. Perimeter, picket fence. Once again, say it out loud. Perimeter, picket fence. So when you're dealing with a rectangle, the first thing I'd like you to do is physically trace the perimeter. So put your pencil on the paper right here. Ready? Walk it around with me. Walk around the perimeter. Walk around the perimeter. That's perimeter. Now I'd like you to label. This is length, and this is width. Now perimeter, to find perimeter, what I always want you to do is physically trace it, and perimeter, of course, is 2 lengths. So we have 2 lengths, 1, 2 lengths, 2 lengths, plus 2 widths. This is just for a rectangle. 2 lengths plus 2 widths. If you can't remember that equation, just think picket fence and walk it around. Now for grass, for area, I'd like you to think of physical grass. So ready? So for perimeter you trace, for area you shade. I'd like you to shade this, please. Shade. And for a rectangle, to find the grass, it's simply length times width. Now, when you write these equations, if I ask you for the perimeter of a rectangle, warning, you do not write this. 2 lengths plus 2 widths. You do not write that. You're like, but Miss Way, it's right there. But why don't I write that? Let me show you. When I ask you for the equation of a perimeter, an equation has an equal sign and has 2 sides. Perimeter equals. Very, very critical. When you write equations, equations have 2 sides. 1, 2, with an equal sign. Equations have 2 sides with an equal sign. Equations have 2 sides with an equal sign. Say it out loud. Equations have 2 sides with an equal sign. Same thing for area. If I ask for the area equation, you do not just write length times width for a rectangle. Okay, that is not the equation. The equation for area is area, if I can get my computer to cooperate here, area equals, again, 2 sides with an equal sign. Let's put this to practice. I'm going to walk you through this problem here using what I call brain and hand techniques. So we're here on the left, and the most important steps in brain and hand, 1 is finger track and read out loud. That means I'd like you to go back, put your finger right by that dot. Even if you're working on an iPad, put your finger there. I'd like you to read this out loud with your finger tracking on either the paper or the screen. Ready? Go. Okay, after you finger track and read, you do this battery. Filter, draw, label, list, cross out. Filter, draw, label, list, cross out. Say it with me. Filter, draw, label, list, cross out. Okay, so filter means you go back and you filter key pieces of information. Ready? Looks like this. Underline or highlight. Mr. Fareed wants to create a rectangular cement patio in his backyard along the side of his house. The length of the backyard is 8 feet longer than the width. Ready? Right above that is, put an equal sign. Is, are, was, were is an equal sign. Each bag of cement costs $6.50, so bag of cement costs $6.50 and covers 12.5 feet squared. The perimeter of the backyard is 64 feet. There's another equal sign. Tax on the subtotal is 10%. Find the total cost. Okay, that's filtering. Now we organize our information in two ways. Either we organize it in a drawing, and we label the drawing, or we label it in a list. So I'm going to write diagram and list. If it doesn't belong in the diagram, it belongs on the list. So here we go. Rectangular backyard. So we know it's a rectangle, so draw yourself a rectangle. Look, I drew a rectangle. Guess what? Cross out that information. You've taken care of it. It helps your brain from getting overwhelmed. The length of the backyard is 8 feet longer than the width. So here's the width. 8 feet longer than, it doesn't say 8 times longer than, it's 8 feet longer than, so it's the width plus 8. So let's write that out. The length equals the width plus 8 feet. Cross it out. Each bag of cement costs $6.50. Now that doesn't really go in our diagram. That's just going to go over here. So we write bag of cement, $6.50. And it covers 12.5 square feet. Covers 12.5 feet squared. Cross it out. The perimeter of the backyard is 64 feet. So that's our length. Here's our width. Ready? Put your pencil right here. Walk it around. Go around, go around, go around, go around. And that, right, perimeter equals 64 feet. Tax is 10%. That doesn't belong in the diagram. That's over here. Tax is 10%. And our goal is to find the total cost. So I'm going to circle that, put a giant question mark there. That's our goal. Okay, that's called draw, label, list, cross out. So draw, label, list, cross out. Now, learn to physically interact with the diagram. I'm going to show you that right now. We have all our information there, so our goal is cost. Okay, so you don't ask yourself, what should I do to figure this problem out? That's super critical. Do not get hung up on should. Let's just ask yourself, what can you do? Okay, let's look at exactly with what you're given. You're given the perimeter, right? So let's write it down. Perimeter equals 64 feet. Let's see. Ask yourself, what do you know about perimeter? Come back here. We just learned something about perimeter. Perimeter, we walk it around. It's 2 lengths plus 2 widths. So can you write it down? Yeah, so I'm going to write perimeter equals 2 lengths plus 2 widths. Let's see what we can do about that. Let's start circling stuff and see how we can put things together. Let's see. We see P there. You see P there? Ready? What does P equal? 64. Do you see another P? Great. That means you can plug it in. So we can do that. That's 64 equals. That's a 2. Ready? I'd like you to circle length. Now, do you see L anywhere else in the diagram? Aha! There it is. But our length has an algebra equation, 8 plus w. So I'm going to substitute that with 8 plus w plus 2, and I already have w. Wowzer, look at here. We're down to one variable. That means we can actually solve something. Now, if you didn't know what to do, just by writing the equation and doing circle, plug, chug, you can get yourself into something that you recognize. Ready? Let's solve for that variable. So we're going to distribute here. So I have 64. Computer is starting to drive me crazy. 16 plus 2w plus 2w. Let's watch this algebra real quick here. Okay, let's collect like terms. We can collect these guys. So I have 64 equals 16 plus 4w. Minus 16 both sides. End up with 48 equals 4w. Ready? Divide by 4. Okay. And then, of course, 4 goes into 48. 4 goes in there one time. 4 goes in there twice. So w equals, let's bring it over here, w equals 12. Now, don't get all happy like you finished the problem, because that's why you box the question. The question does not ask you what is the width of this yard. The question wants you to get the total cost, so keep that in mind. So ask yourself, if you come down here, ready? Circle W. Just circle it. Ready? Circle it. Where else do you see W? Ready? Draw an arrow. Plug it in, please. That's 12. You also have 12 here. And that gives us our length, 8 plus 12, which means our length is 20. Now, we have the length and the width. So ask yourself, what else could we do? We have the length and the width. And if you look back here, you learned about perimeter. And we learned about area. And if we wanted to find the area, area is length times width. Now, we're making cement. So ask yourself, if you're going to deal with cement, is cement a perimeter issue? Or is cement like grass? And cement's like a grass issue, so we need to find the area. So over here, I'm going to write out the equation for area. Area equals length times width. Notice I used an equal sign with two sides. I didn't just write length times width. It's area equals. So area equals. Now I circle, plug, chug with equations. That means I physically circle the L here, and I look for L above. And I have it right there, L equals 20. Physically circle, that's called physical pickup. That helps your eyeballs not to pick up the wrong numbers. Okay, and I'm going to draw a little arrow down here. I'm going to plug that in. 20 times. But Miss Way, this is tedious doing physical pickup. I don't care. I've been teaching for 15 years. Students make super simplistic mistakes because their eyeballs pick up the wrong numbers. If you circle Circle, plug, chug, physically pick up the numbers you're hunting for. By physically circling them, you're much less likely to make mistakes. That's called circle, plug, chug. So we circle, we plug it in, and chug is my euphemism for just doing math. We're going to go 20 times 12. 10 times 12 is 120, so we double it. We have 240 feet squared. Wait, there's more, because we just got the area. Now let's look at the information we have here. Our bags of cement cover 12.5 feet squared. Look, and we have 200 feet squared to cover, and we want to figure out how many bags. So each bag covers 12.5 square feet. So by calculating the bags, we divide our area by 12.5. That's going to give us the number of bags. I know you're freaking out with the decimal, so if you think you need a calculator, let's work it out. 240 divided by 12.5. And that means we need 19.2 bags. Warning, different between standard math and real life. In standard math, you'd round this down to 19. Problem is, you need that 0.2 in order to make this patio. So you're not buying 19 bags here. You're buying 20. So we need to purchase 20 bags. At $6.50. So that's going to be 20 times $6.50. You had $130. That's your subtotal. So we're just going to write sub is $130. Now your tax is 10%. So you simply take 10% of 130, and that's 13. So your total cost, my friends, for the cement in the patio is $143 total. There's your total. Okay. Now, this looks freakishly long, but if you learn the techniques that I'm telling you to, you learn to finger track read, you filter, draw a label list, cross out, ask yourself what you can do, use equations that have two sides with an equal sign, you are much less likely to get stumped and frustrated. So I'm going to set the timer for 5 minutes. Your goal is to follow the same process and attempt to solve this one problem in 5 minutes. Ready? Go. Finger track read, solve. All right, let's do this. Finger track and read out loud. Miss Johnson wants to plant a flower marigold border around her small herb garden. The herb garden is rectangular and the length of the garden is 3 times longer than the width. The area of the garden is 108 feet squared. It will take 2 pots of flowers per linear foot to create the desired border around the garden. The flowers cost $3 per pot. How much will it cost to plant the marigold border around Miss Johnson's herb garden? Okay, again, don't be intimidated simply because this is a multi-sentence problem. Should have finger tracked to read out loud. Now we filter. We're making a border here. The border is rectangular. The length of the garden is 3 times longer than the width. The area of the garden is 108 feet squared. It takes 2 pots of flower per foot to create the border. The flowers cost $3 per pot. How much will it cost? We're going to calculate without tax this time. Ready? Everything I've highlighted either belongs in a diagram or a list. Okay, so it's a rectangular garden, so the first thing you should have drawn is a rectangle. So cross it out, it's a rectangle. We're looking for the border. The length of the garden is an equal sign, is 3 times longer than the width. So the length is 3 times longer than the width. Notice it doesn't say 3 more than, it's 3 times. The area of the garden, we already know the area, so we're going to write it here. My stupid computer would cooperate. Come on, computer. All right, there we go. The actual area of the garden is 108 feet squared. Then we're told that there's 2 pots of flowers for every foot. So for every foot, linear means line. So for every 1 foot, we're going to need 2 pots of flowers. It's my measly attempt at flowers and the pots. Okay, so 2 pots of flowers per foot. And they cost $3 each. So each of these costs $3. With no tax, what does it cost? Now, our ultimate goal is a border. So realize we're working with a border here, but we're given the area. Okay? So draw, label, list, cross out, which we have done. Draw, label, list, cross out. Now, ask yourself, what can you do? If you feel stuck here, you should have just said, well, I have area. I could at least write the equation for area, can I? So let's write that. Area equals length times width. And I know we're talking about border here. So border is going to be a perimeter issue, so I write that equation down. Do I need it? I don't know. But again, you always ask yourself what you can do. 2 lengths plus 2 widths. Now we circle, plug, chug. Let's see what we have here. So I come here, I circle the word length, and I come up and, oh, there's length, and I can replace something with length. L3W, so I plug it in. 3W times W equals circle area. There's area. Oh, looky there, there's a number, 108. Okay? Isn't this amazing? We're down to 1 variable. You can actually solve this. So let's solve for the variable here. Bring this real close so it's easy for you to see. W times W is not 2W. W times W is W squared. So this reads like this. 108 equals 3W squared. Our goal is to get W by itself, so I'm going to divide both sides by 3. That cancels. 3 goes into 10 3 times with 1 left over. 3 goes into 18 6 times. So I have 36 equals W squared. Now to solve for this, what I'm about to show you is wrong. The opposite of squaring is not dividing by 2. What I just showed you was wrong. The opposite of squaring is square rooting. So we're going to square root both sides. And we find out that W, the width, is 6. So you ask yourself, what can I do with the W? Well, I can come back up here and plug it in. So my W equals 6. There's a W up here too. Let's do 3 times 6. That means my length is 18. Which means now I can do my border. Let's walk the border around. I'm going to go 6 plus 18. That's 24, right? Plus 6 plus 18. That's 24 plus 24. So our perimeter ultimately is 48, and that's feet. That's not feet squared because it's a border. Okay, so we have 48 feet now, and what we figured out is that for every foot we want 2 plants. Right? That's what we figured out. For every foot we need 2 plants. So we come down here. I'm going to write for every foot we need 2 plants. Plant and a plant. And we have 48 feet, so we're going to take 2 and times by 48. If you're doing single-digit multiplication, please get in the habit of doing it by hand. It's good for the brain. So 2 times 8 is 16, carry the 1. 2 times 4 is 8, plus 1 is 96. So I need 96 plants. They're $3 each, so I'm going to times it by 3. Again, if you're doing single-digit multiplication, I beg you, do not use a calculator. Do it by hand. It's good for the brain. 3 times 6 is 18. Carry the 1. And 3 times 9 is 27. Plus 1 is 28. And you should have gotten a total of $288 for this flower border.